areas of rectangles, parallelograms, triangles, and trapeziums, using these 4 equations. Before we start, I just want to point out what all of the different letters mean. The capital A on the left of each equation stands for area, which is all of the space inside of each shape, and is what we're trying to find. Then L stands for their length, which is how long the shape is. W stands for width, which is how wide the shape is. B stands for base, which is just the length of the bottom side. And H stands for height, which is how tall the shape is. Then the last one is this lowercase a, which we find in the trapezium equation, and represents the length of the top side of a trapezium. Okay, so let's now go through each of these one by one, and we'll start off with the rectangle. The formula for a rectangle is area equals length times width. So if this rectangle was 7 centimeters long and 3 centimeters wide, we'll just multiply the length of 7 centimeters by the width of 3 centimeters. So that would be 21, and the unit would become square centimeters. Before we move on, I just want to point out that you can also think of the equation as area equals base times height, where the base would be the 7 centimeter side, and the height would be the 3 centimeter side. But it works in exactly the same way, so the area would be the base of 7 times the height of 3 to get the area of 21 square centimeters. Next up is the parallelogram, and this is basically just a pushed over rectangle, and so has basically the same formula. This time though, we do base times the vertical height. So it's not this side length that we have to use, but the vertical height between the bottom and the top. So if, for example, this parallelogram had a base of 9 centimeters and a vertical height of 4 centimeters, then its area would be 9 times 4, so 36 square centimeters. For the triangle, the formula is area equals 1/2 times its base times its vertical height. So if this triangle here was 12 meters long on the bottom and 5 meters tall, we'd do 1/2 times the base of 12 times the height of 5, which would give us an area of 30 square meters. Now, to help you understand the equation a bit, the reason that we have to have the 1/2 part is that if we just multiplied the base and the height together, we'd calculate the size of this rectangle instead, which in this case would be 60 square meters. Our triangle, though, is only half of this area, so we have to take that into account by multiplying our equation by 1/2. And finally, bear in mind that if the triangle isn't a right angle triangle, like these two, then you still use the 1/2 times base times height equation, but you just have to be very careful about picking the height to the highest point. The last one we have is the trapezium, with the formula that area equals a plus b over 2 times h, where a is the top side, b is the base, and h is the vertical height. Now, the reason that this formula looks a bit complicated is that in trapeziums, the top and bottom sides are always different lengths. And this means that we can't just use the formula area equals base times height, as we would with a rectangle or a parallelogram. Instead, we have to find the average length of these top and bottom parallel sides, and then multiply that average by the vertical height. So to find the average of the top and bottom, we have to add them both together, which is this a plus b part, and then divide that by 2. So this whole a plus b over 2 part is effectively just the average length of the trapezium. Then all we have to do is multiply that by the vertical height, and we get the area. So to give that a go, if this trapezium had a bottom length of 14 centimeters, a top length of 8 centimeters, and a vertical height of 7 centimeters, then to find its area, we'd need to add the 14 and the 8 and divide that by 2, which remember is effectively the average length of the trapezium. And then we can multiply that by the vertical height of 7 centimeters, which if you put it into your calculator will give you an area of 77 square centimeters.